they've become so popular worldwide? Well, I'll tell you. Eggs have been consumed worldwide ever since the 2nd millennium BC. Indian wild red jungle fowl, which is the ancestor of the modern chicken, was dispersed throughout Europe, China, and the Middle East. Also, chickens were brought to the New World on Columbus's second voyage in the late 15th century. And in March 2015, egg production totaled a staggering 7.42 billion, which increased a total of 1% from last year. Rate of lay per day in early April averaged 79.6 eggs per 100 hens. Eggs are a very important ingredient in many recipes because the protein in the egg white coagulates as it's heated. Eggs are utilized in many recipes as a structural component. Stiffly beaten egg whites expand as they are heated and are used as leavening in angel food cakes. It also supplies in cake batters. In cake batters that utilize the entire egg, the egg acts as leavening as well as providing moisture and firm texture. Soups and sauces use eggs as a thickening agent. Ice creams often include eggs to prevent the formation of ice crystals, which can ruin the product. But the plain egg is also very popular alone, and it's eaten by millions each day for its own unique flavor and nutritional value. They may be boiled, poached, fried, scrambled, or baked.
A typical eggshell is covered in more than 17,000 tiny pores and composed of CaCO3 crystals. It is semi-permeable and coated in a thin outer layer called the bloom, which keeps out germs and dirt. Located in between the shell and white of an egg, these protein membranes provide bacterial defense. Composed of keratin, they are remarkably strong and resistant to tear.
After the egg is laid and the contents cool and contract and airspace forms, the air cell is generally between the two membrane layers at the thicker end of the egg and can be seen as a crater when an egg is hard-boiled. The space grows larger as an egg matures.
Also known as the egg white, the albumin is composed of 4 alternating layers of thick and thin and contains about 40 different proteins and water.
These cloudy ropes of egg white hold the yolk in place like anchors and attach the yolk casing to the membrane along the eggshell. When the chalazae are more prominent, it indicates the freshness of the egg. The vitelline membrane serves as a transparent casing for the yolk.
The yolk is rich in iron, vitamins A and D, phosphorus, calcium, thiamine, riboflavin, and lecithin, which is an emulsifier. It contains less water but more protein than the whites, as well as some fats. The color of the yolk can be anywhere from light yellow to a deep orange, varying as a result of the feed and the breed of the hen. Egg white is about 12% protein, and the egg yolk itself is about 16% protein. This means that any alteration to the structure of these proteins will, in turn, significantly alter the structure of the entire egg. All proteins are made up of chains of amino acids. When a protein is in its native state, the amino acids are folded in a very specific way that gives the protein its shape. And that shape, among other things, gives the protein its properties. However, when you apply an external stress on the egg, such as heat from cooking an omelet, the proteins will undergo a process known as denaturation as their globe-like structure deforms.
Denaturation of proteins involves the disruption and possible destruction of both the secondary and tertiary structures. Since denaturation reactions are not strong enough to break the peptide bonds, the primary structure remains the same after a denaturation process. Denaturation disrupts the normal alpha helix and beta sheets in a protein and uncoils it into a random shape. In tertiary structure, there are 4 types of bonding interactions between side chains, including hydrogen bonding, salt bridges, disulfide bonds, and non-polar hydrophobic interactions, which may be disrupted. Heat can be used to disrupt hydrogen bonds and non-polar hydrophobic interactions. As we apply heat to the egg, like when frying an egg or making an omelet, the extra energy causes these proteins to move around more vigorously, colliding with each other and weakening the bonds between the different protein strands. As these bonds become weaker and weaker, their globe-like structure starts to unfold and the protein becomes denatured. These strands of proteins are then free to make these bonds with each other, causing it to coagulate, which is why the egg whites go from transparent to opaque as the egg is cooked. Overcooking creates too many of these bonds, so the proteins join together too tightly and you end up with rubbery eggs.
Egg white contains several mucoproteins, where the protein is attached to carbohydrates. In the egg, these serve as nutrients for the growing embryo and as support and protection. Over half of the protein in egg white is of one type, ovoalbumin. It denatures at 176 degrees Fahrenheit, forming the solid white mass we see at breakfast. The next most prevalent protein is ovotransferrin, which makes up about 12% of the proteins in egg white. It denatures at a lower temperature, about 145 degrees Fahrenheit. The third most prevalent protein is ovomucoid at 11%. Ovomucin is the main gelling agent in egg white. The first protein to denature when heating an egg white is the ovotransferrin. As it unfolds, it binds not only to other unfolded ovotransferrin molecules, but to other proteins that are not yet denatured. The ovomucoid and ovomucin molecules, which do not coagulate with heat by themselves, can thus be incorporated into a strong gel with the ovotransferrin and ovoalbumin. Avidin makes up a very small portion of the egg white, less than 0.1%, but it binds very tightly to the essential nutrient biotin, making the biotin unavailable as a food source.
This molecule is the amino acid known as lysine. It is one of the 9 amino acids that comprise the proteins within an egg.
Of lysine is C6H14N2O2. The black spherical balls are carbon, the white ones are hydrogen, the blue are nitrogen, and the 2 red ones are oxygen. Depends when a protein just denatures. Just kidding, this is an amino acid, they don't break down. That would be against the laws of biology.
A century egg is a preserved egg, also known as 1,000-year, millennium, and sometimes pine pattern eggs. They are preserved during a period of anywhere from a few weeks to a few months by soaking the duck, quail, or chicken eggs in a saline solution. This saline solution also contains clay and salt and sometimes ash, quicklime, and rice hulls. The egg yolk takes on a creamy cheese texture and the whites become a darkish jelly. Oftentimes, the century eggs are eaten with pickled ginger root or occasionally with congee or rice porridge like I'm doing right now. They often have a strong pungent odor and have intricate patterns on their surface. According to legend, the eggs were discovered during the Ming Dynasty in China, where Hunan residents supposedly found duck eggs in a pool of flaked lime and tried them out.
Am I still on the camera?
Well, now I'm recording.
Why?
Chemistry in action.
Ever wondered about the history of eggs and how they become so
If your mom's here.
well?
Okay, now we gotta restart it. Go ahead.
Hope you realize that's on video.
I really hate my life.
Good luck in the formula.
No, don't follow me!
The ice yolk.
Oh my god.